Hey there, welcome back to the channel. So this is Ramandeep Singh, and I hope you are doing really well, and you people are learning something from this series. And today, in this particular series, in this particular session, problem solving session, we will be solving the next problem of the CSES session. That is this uh, building roads. We will solve building roads, which is the third problem of the graph section, graph algorithm sessions section of this particular CSES website, and we will solve this problem in this video. So stay tuned with me. I hope you are learning really new things and new problem solving techniques from this series. And there are few prerequisites to understand the solutions. I am assuming this particular series is for people who are a little bit experienced in data structures and algorithms. They know what is what is DFS, what is BFS, what is raster algorithm, what is Bellman Ford, what is Kruskal, Prims. These algorithms they are aware of. DSU, these things. Only then you will be able to understand these things really well. So I recommend you people to please first understand those algorithms, the fundamentals, and then move to the problem solving part. So let's start solving the problem without wasting any time. So let's read the problem statement. We have this is building roads. Byteland has n cities, m and m roads between them. The goal is to construct a new road so that there is a route between any two cities. So what do we have to do in this problem is we have n cities and we have m roads between those cities, right? The goal is to construct new roads so that there is a route between any two cities. So pick any two cities of the you pick any two cities of that particular byte land, of that state byte land, and there is a way, there is a route between those two cities which you have picked. Now the task is to find the minimum number of roads that you people need, and also determine which roads should be picked. So to find minimum number of required to connect the simple as that. Okay, first let's understand this really with example 1 2 3 4 and 2. So there's a road as a bin 3 and 0 and 2 and 1 2 cities they should not a route in both cities, right? We are route in both cities start and others. That's what I want to know. Okay, there are classes because there are we need to print an integer k which represents the number of roads which are required, and then print k lines describe new roads. You can print any valid solution. So that means there are multiple solutions. So one solution is to build a road between 1 and 4 to connect uh, these two, we can say connected components, or we can say group of cities. So we have two groups of cities. We can divide the entire state into two groups of cities. The first group contains 1 and 2, and the second group contains 3 and 4. So in order to make them a single group, that is a byte land, we need to connect them. Now we can either connect 1 or 3. So we can put a road here. We can connect 1 and 4. We can connect 2 and 3. We can connect 2 and 4. So how many roads are possible? 1 2 3, 1 2 4, 2 2 3, and 2 2 4. So these are the roads which are possible. These are the roads which are possible. So any of the four roads are valid. Any of the four roads are valid. And we need to pick exactly one of these four. Okay? We need to pick exactly one of these four roads. Okay? So which one you're gonna pick, that is your choice. So all we need is just pick one node from the first component, pick any other node from the second component, and you just print those two nodes. So you can print 1 and 3, you can print 2 or 3, you can print 1 and 4, you can print 2 and 4. Any of the four is valid. Let's take one more example. Let's say we would have like 5 here, and then you may have, let's say there is a road between 1 and 3. Now the entire byte length is connected. We have at least one route between any two cities that we pick in this particular byte length. Now we don't need any extra road to be constructed so that we can move from one city to another city in that particular state. So here we can see that the answer for this would be 0. The answer for this would be 0. We don't need any extra road. If this would have been missing, then how many possible answers we can have? Like 1 and 3, 1 and 4, we can build a road from 1 and 3, we can build a road between 1 and 4, 1 and 5, 2 and 3, 2 and 4, 2 and 5. These roads can be built here, right? I hope thing is getting clear to you. And let's say we have one more component, that is 6, and then we have, let's say, 7 are connected. Now how many roads do we need? We need exactly 2 roads to connect these 3 components into one component. That road can be between 1 and 4, and then from 4 to 6, 1 and 3 and 3 to 6, 1 and 5 and 5 to 7, like that. So one node from this component. So just pick one node from this component, pick one node from second component, pick one node from this component, and just list them. So 1, 3, 6 is a possible answer. That's all. Not 1, 3, 6. We'll say it 1 and 3, and then 3 and 6, right? 2 roads. So 1 and 3, and then 3 and 6. That's all. So how would we now we are simply calculating the number of connected components. That will be let's say the number of connected components are 3. Then the number of roads that we need would be 3 minus 1, that is 2. If the number of connected components are 2, the number of roads to connect them would be 1. If the number of connected components are 5, then the number of roads we need would be 4. So for any k connected components, the number of roads would be k minus 1. Okay, let's jump to the code implementation part. So all we need to do is to construct the graph from the given edges. So we have 4 nodes in this graph. For this particular graph that has been given to us, we have 4 nodes, and we have 2 edges. So we construct the graph, and then we run DFS. So we run DFS from 1. It is going to visit the entire component, and we pick 1 from that particular component. We pick this node 1, and we push it into an array. Now we perform DFS on the second component. Let's say we start from 3. So we push 3 into the answer, and we perform DFS over it. Then we pick the node from the third component. Let's pick 6, and we push 6 into the answer array, and then from the answer array, so now we have 1, 3 and 6. We have 1, 3 and 6. Okay. Now all we need is to just print consecutive 2 nodes, 1 and 3, and then 3 and 6, like that. That's all. That's all we need to do. So just pick one node from the component, and then keep pushing it into the answer, and then print consecutive 2 nodes from the given answer array. So we picked 1 from the first component, then we picked 3, and then we picked 6, and now you put 1 and 3, and then 3 and 6, like that. Okay. I hope it is clear to you. So let's jump to the code implementation part. So we will read the number of nodes and then the number of edges, and then we read the graph that is in an adjacency list. Since it is one base, so we're gonna add them like this. So all you need is this answer, or we can say answer. Then you also need vector temp. So in this vector you will push a node from each component. Then let's start. We also need a vector that would be, the visited array, vector bool visited. ठीक है. If I is not visited, you are going to, like, increment the answer by 1, or you also don't need to count the number of components as well. Just call the DFS and push this node into the vector temp dot push back I, and just call the DFS for that node. Pass visited, pass adjacency list as well. And not n, here you need to print temp dot size, and here you will print okay. And yeah, that's all. Now let's say this. We have visited true, then for ठीक है. So that's where we have to, so we are just performing a normal DFS here, and here just perform the DFS how many times, and then that's all. Easy one. Why it's not working? Okay, 113. So we can submit it here. Let's try submitting it. Got it accepted. ठीक है. That's all for this video. And what's the time complexity for this? Simple. It's just a simple DFS. So the time complexity for this will be big of n. Since it is a graph, it would be big of n plus n. And the space complexity will also be big of n. Right? Why? Because of the call stack. Because of the call stack. So I hope it is clear to all of you people, and if you have any doubts, if you have any problems, please try and comment and try to share this video as much as possible so that it reach other people as well. And I'll see you in the next one. Till then, take care. Bye bye.